Law of conservation of electric charge. Before going to conservation laws, first we should know what isolated system is. Isolated system. An isolated system is a thermodynamic system that cannot exchange either energy or matter outside the boundaries of the system. There are two ways in which this may occur. 1. The system may be so distant from another system that it cannot interact with them. 2. The system may be enclosed such that neither energy nor mass may enter or exit. Isolated system looks like this. Conservation laws. Conservation law, also called law of conservation, in physics, several principles that state that certain physical properties, i.e., measurable quantities, do not change during time within an isolated physical system. There are 5 conservation laws in classical physics. 1. Conservation of charge. 2. Conservation of energy. 3. Conservation of linear momentum. 4. Conservation of angular momentum. 5. Conservation of mass. Conservation of charge. Charge conservation was first proposed by British scientist William Watson in 1746 and American statesman and scientist Benjamin Franklin in 1747, but the first convincing proof was given by Michael Faraday in 1843. Statement. The law of conservation of charge states that electric charge can neither be created nor destroyed. It can only be transferred from one system to another. The net quantity of electric charge is always conserved. For example, a positive rod Q plus 4 charge is rubbed with neutral sphere Q equals 0, then charge of rod will be transferred to sphere. Before and after collision charge, the net charge will be conserved. Q net equals conserved. Integral form. The integral formulation of conservation of charges, where J is the current density, ρ is the volumetric charge density, Q is the total charge inside the volume, A is the surface area of the volume, V is the volume. Differential form. With the use of the divergence theorem, above equation can be written in differential form. Del J equals minus partial ρ partial T. Conservation of charge formula from Ampere-Maxwell's law. The conservation of charge equation is not an independent equation that needs to be included with Maxwell's equations. It can be derived from the Ampere-Maxwell law and Gauss's law for electric charges. Del times H equals J plus partial D partial T. Taking the divergence and using del D equals ρ F and a vector identity yields del times H equals J plus partial D partial T cross del J equals minus partial ρ F partial T. Note that in Maxwell's equations J refers to the free charge density. Thank you, and don't forget to subscribe my YouTube channel.